Well, as this video is going to go through both activities on page 113 in relation to the parabola and the ellipse. The first one here on the left, 11.11, it tells the figure shows a design for a Star Trek badge. The curve AD is a semi-parabola with the vertex at D. So basically this is going to be the top point of our curve. For imagine if it was to go back around the opposite way. The curve in the background is an ellipse with a major axis of 140 mil and a minor axis of 80 mil. So we have an ellipse drawn in there as well. So it's a partial one. So we won't be drawing a heavy in between here, here, or here. Then it says draw the given design. Note, use point A above as the starting point. So point A here is given to us just up there as well. So the first thing we're going to draw is the parabola. I need to draw a rectangular box to fit it inside. So we can see there, if I just move this down, the width of the box is going to be 70 mil, and the height of our box for our parabola is going to be 150. So very simply just measure 150 there. And because the parabola is going to be going along here, and it's going to end up at a vertex up here at D, we're going to divide this top into 5 equal parts, connect these all back to D here, and we divide this line to 5 equal parts. We'll take those horizontally to meet up. So I'm going to pick 5 just so we have plenty of points, because it's going to be a big enough curve going from here all the way to there. So line out at a random angle, as always, and step out 5 equal distances. So 1, 2, 3, 4, and 5. And then we use slide and set squares to connect those back. So you can just see the top there now. So 1, 2, 3, 4, and 5. That connects back there. And then just use slide and set squares then. And they all connect to D then, because the parabola is going to be on its side. Then go divide up this into 5 equal parts. So what we'll do is take a line out an angle once again, step out our 5 equally spaced distances, 1, 2, 3, 4, and 5. Connect the end there, and then use the slide and set squares again. Join that in there, 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 and there. And they'll be taken horizontally across. So this is the fourth one here. So I'll connect to that one there. Third one connects to the third one there. Second one connects to the second one there. And the first one connects to the first one there. And we already have our fifth and our 0 point there at A. And nice and neatly then, drawing a freehand curve, connecting those together. And then afterwards then, one continuous line. Draw it heavy then as a result, all the way around. So there's the curve, probably for AD. For point C, we're told that it's on the line A there going down, and from D we measure up 40 mil. So up 40 from here. That point there is now point C. And point B is on the same line as D, and it's 45 mil to the right of that line there. So we step out 45 mil to there. That gives me point B. And then B connects to C. B also connects to A. And then we have a radius 100. So I just move that down there so you can see. It's going to be a radius 100 here. So we know that this point here and this point here is on the circle, or on the arc in this case. So that means the center has to be 100 mil away from both those points. So I take 100 mil on my compass, swing an arc from D. So somewhere along that arc there, it's always going to be 100 mil away from D. Swing from C as well. Or the two cross, that's going to be 100 mil away from C and 100 mil away from D. And now I can draw in my arc there in between, just like that. The last part then is to draw the ellipse. We're told the major axis is 140, so that means we half that. We're going to be taking 70 mil for our major circle, and a minor axis of 80 means we're going to take a radius of 40 mil for our minor circle. For the center of the ellipse, we're told it's up 10 and then across 10 from C. So up 10 is that point there, across 10 to the left, and there is the center of our ellipse. So you take a radius of 70, because that's the half of 140, and draw a circle lightly, and that's going to be our major circle. And our minor circle is going to be a radius of 40. The method for drawing the ellipse is the exact same as always. We divide our circle into 12 equal parts using our 30/60s. You can see there's going to be a lot of lines, so we have to make sure we note which ones we're using. So 30/60 going that way, and then 30/60 going the opposite way. And take our vertical line here and our horizontal line here. So you can see it's very, very messy. So what I'll do is I'll just use colors to show all of my lines, so you can see clearly which ones I'm drawing from. So what I'll do is I'll just use this green color here just for my divisions, just so you can clearly see. So there's my vertical and horizontal, and then you can clearly see now there's a 60 degree going one way, there's that 30 degree going this way, and then the opposite way is going to be 60 degrees here, and then 30 degrees going this way. Just like that there. So I'll just zoom in a bit so you can see that. Now, as always, when we're drawing our ellipse, where each of these hit the major circle, we take them down for the upper half. So for example, this one here goes down, this one here goes down. Where the same lines hit the minor circle, they go across. So this line here hits the minor here, that goes across where it intersects that line, gives me a point here. This one goes across where it's this line, gives me a point there. So just like that there. Same on the opposite side. Take them down, and where they hit the minor, take them across. Point there. Take this one across, point here. And we already have our top point, our two widest points. Same in the bottom. This time they go up and across. So that goes up there, and up there, and then across to give me that point, across to give me that point, and then up there, and across, giving me that point, and giving me that point. And then I can draw my ellipse. And then afterwards, just go in heavy over the part I want to keep. So all the way around to there, it's light, and then it's heavy from here, around to there, and then finally the last bit, all the way around to there. And that completes that question there. So for the next one, on the right hand side, 11.12, it says the figure shows the design of a tower. Part A, then the curve AB is a semi-parabola with vertex at B. So this time the vertex is going to be here. So the curve is going to be along this way. So we divide our side here, our rectangle, we're going to be connecting all those points to B. When we divide the base, we're going to be taking those across then. The curve DC is an identical parabola with vertex C. So basically this is another parabola, but it's the exact same distance. It's basically a mirror image along that center line there. And it tells us draw the parabolas and outline the tower. Then part B, the curve GH is an elliptical with focal points F1 and F2. The major axis is 110 long as shown. Determine the length of the minor axis and complete the given tower. Note, use point A above as the starting point. So we are given point A here. So first of all, we're going to draw our parabola, and we're told the box is going to be 180 tall. So I draw a vertical line there, measure up 180 mil. Take that across there, and there. And the width then is 72 mil. So you can see it on the top there, 72. And there's point B. So the parabola is going to be going along here. So when I divide the base here into 5 equal parts, step out 1, 2, 3, 4, and 5. Connect that to A. Then use my second set square. And then slide it up like that there to give me 4, 3, 2, and 1. And connect all those back to B then, with B being the vertex. I'll divide this side here, take a line at a random angle. Once again, step out 5 equal distances. 1, 2, 3, 4, and 5. Join that to the top there. And once again, using sliding set squares, slide that across to give me that point, that point, that point, and finally that point there. So we have 1, 2, 3, 4, and 5, and we connect those across horizontally. So our first one here, our second one here, our third one there, and our fourth one up there. Now we have our curve drawn in there on that side, and draw that in heavy then as well, just like that there. And then the distance then that we go across, so it's 10 mil between B and C. So across there for the opposite point of the curve, there's C. Center point is going to be 5 mil obviously, because 5 mil is a half of 10. There's our central axis. So I'll just mark that in there that you can see it. Just like that there. And then what we have after that then is going to be 72 the opposite side. Measure out 72 here. Take that down. Gives me point D, so just move this across so you can see it. Point D there. And now we're going to use axial symmetry to take our heights across. So it's basically going to be mirror image. I'm going to flip this across here to give me the same result. Instead of drawing the whole parabola setup again, we can just take our points across. So we use our center line here, that distance there, step it across to here, the next distance down, step it across, always going from the central axis, that one across there, that one across to there. And same thing, draw your curve all the way down like that, and then go over it heavy. And then we can do is we can measure up 12 to give us the triangle at the top. So that goes straight up there and straight up there. And then it's a further 12 after that. And they connect there and there. And then the ellipse is the last thing we need to do. So we're told the width in total is 110, so divide that in two. We get 55 mil each side. 55 is 110. That gives me point G, point H. Our focal points are then 76 in total, so we divide that by 2. That gives us 38 each side. So 38 and 38, using 76 there. There's F2 and F1. And remember back, sometimes we're given the major and the minor. If we take half the major, swing from the minor, we get our focal points. This time we do the opposite. We take half the major, swing it from the focal point, and that'll give us our minor circle as a result. So we take half the major, swing from the focal point, and that'll give us where our minor circle is, because we already have our major. So we can draw half there, our semicircle there, and then it's the same method again. Divide it up into 30/60s, so I'll just zoom in there so you can see. And just turn the light on, just one sec. Just make it a bit brighter. And then using your 30/60, same method again. We're drawing an ellipse where the points hit the major, take them down. So both sides I can do that. And then where the lines hit the minor, take them across. And that gives us all of our points. And then we can draw in our ellipse in the top half then as a result. And just close off DH and AG. And that completes the question there. So hopefully that video helps anybody may have been stuck on either of those two questions.